Welcome to the deep dive. Today, we're going deep into AI in medicine.
Oh, yeah.
Specifically, a new model called Titan.
Interesting.
This deep dive is, well, custom made just for you.
Wow.
And get this, Titan is really pushing the boundaries
Really?
of what's possible in computational pathology.
Hmm.
By the way, that's using computers to analyze medical images, to diagnose and well understand diseases.
Cool.
Now, for this deep dive, we've got excerpts from a research paper.
Oh, wow.
From, well, let's just say some serious heavy hitters. Harvard, MIT,
Yeah.
and the Broad Institute.
So cutting edge.
Exactly. Like, seriously cutting edge stuff.
Okay, so what's so fascinating about this paper is how it tackles this challenge that's been holding back computational pathology. Traditionally, you see, AI models could only look at tiny pieces of a biopsy slide. Imagine trying to diagnose a whole disease by looking at a single cell instead of the whole tissue sample. It's like you need that full context.
You need the bigger picture.
Yes, to really understand what's going on.
So how does Titan change this?
Titan analyzes whole slide images.
Whole slide images.
Yeah, or WSIs for short.
Okay.
These are huge, high-resolution scans of entire biopsy slides.
Right.
Instead of little snippets, it gets the full story.
The whole enchilada.
Exactly.
So what can Titan see that other models couldn't?
Well, it can see how the cells are organized. Their shapes, sizes, how they're interacting with each other.
Fascinating.
All these subtle details can make a huge difference when making a diagnosis.
That's amazing. So much information packed into a single slide.
I know.
How does Titan even learn to make sense of it all?
Well, the researchers trained it on a massive data set of over 335,000 WSIs from 20 different organ types.
335,000.
Yep. Imagine that this AI has seen more tissue samples than most doctors ever will.
That's wild.
And not just images, they also trained it on actual pathology reports.
Like the written reports?
Yeah, those detailed write-ups pathologists make.
Wow.
They even used another AI called PathChat to generate even more captions for different parts of the slides.
It's like AI assisting AI.
It is. It's AI helping AI.
That's incredible. Can you unpack that a bit more?
Sure.
What makes PathChat so game-changing?
Well, think about it.
Yeah.
To train an AI this way, traditionally, a human pathologist would have to annotate every single slide.
Yeah.
It would take forever.
Oh, for sure.
And cost a fortune.
I can imagine.
But by using PathChat
to
create those extra captions, they were able to train Titan on a much larger scale without a human having to label everything.
It was like a much smarter way to train these AIs.
Absolutely.
So after all this intense training, what can Titan actually do?
Hold on to your hats.
Okay.
Because this is where things get really interesting.
I'm ready.
Titan can go way beyond just making a simple diagnosis.
Okay.
It can predict cancer subtypes.
Cancer subtypes.
Even the incredibly rare ones that doctors might only see once in their careers.
That's incredible.
It is.
Can it do even more than that?
Oh, yeah.
Okay, tell me more.
Hold on to your hats.
Okay.
Titan can also predict which patients might respond best to certain treatments and even estimate a patient's chances of survival.
That's incredible.
I know, right? This could completely revolutionize how doctors personalize treatment plans. And get this, it can even generate entire pathology reports.
Wait, hold on.
Yeah.
It can write reports?
It can.
Like reports that a human doctor could read?
Oh, yeah.
That sounds almost too good to be true.
It might sound like science fiction, but it's the reality of where AI is heading in medicine.
That's incredible.
And remember, even with all of these capabilities, Titan is not meant to replace pathologists. It's more like a superpowered assistant, able to take on those, tedious, time-consuming tasks and free up the human experts to focus on what they do best.
Makes sense.
Like interpreting the findings, considering the patient's individual circumstances, and making sure they receive the best possible care.
So it's like giving pathologists a bionic eye to see things they might otherwise miss.
Yes.
It doesn't replace their expertise.
Right.
It enhances it.
Precisely.
That's fascinating.
Titan is trained on data created by human pathologists.
Right.
It learns from the best.
So it's like having the combined knowledge of countless experts all at your disposal.
Exactly.
This all sounds amazing, but how does Titan actually help doctors when they're faced with a challenging case? Especially when dealing with those rare cancers. There's something in the paper about its ability to find similar cases in a huge database.
Oh, right.
Like some super-powered search engine for pathologists.
You're absolutely right.
Yeah.
This is where Titan's ability to analyze those whole slides and recognize those subtle details becomes incredibly powerful. Imagine a doctor facing a really puzzling biopsy. Maybe a cancer they've never seen before.
So Titan could help them find a match.
Exactly. Titan can sift through millions of slides.
Millions?
Yes, and pinpoint those rare cases that might hold the key to a diagnosis.
Wow.
It's like having a team of the world's top pathologists available for consumption.
Right at your fingertips.
Yes, instantly.
That's incredible.
They tested this ability using a special dataset called rare cancer.
Rare cancer.
Which included 186 different types of cancer, including 43 really rare ones.
Okay, so this isn't just some futuristic concept.
Nope.
It could have a real impact on patient care right now.
It can, yeah.
Is that right?
That's the most exciting part.
Wow, that's incredible.
Titan's analysis is readily available and can be integrated into existing systems right now. It's not some far-off technology.
We've covered a lot already.
We have.
But I'm dying to hear more about the language processing side of Titan.
Oh.
The paper mentions that it can actually understand the text in pathology reports. It's like it can read and interpret complex medical language.
It can.
So what does that mean in practical terms?
Well,
we'll find out right after this.
What?
So we're back and ready to explore like the linguistic side of Titan.
Yes.
It's not just about images. You know,
right.
This AI can understand the language of pathology reports.
That's right. Titan is what we call a multimodal model, meaning it can process both images and text.
Okay, so it's like having a pathologist who can see those intricate details.
Yeah.
But also read and interpret like the accompanying reports.
Imagine this.
Okay.
A doctor's looking at a biopsy, sees some unusual features. They can actually describe those features to Titan.
Really?
Using plain language.
Wow.
And Titan can then search its database for similar cases.
So even if the visual similarities aren't obvious,
exactly,
they could still find a match. That could be huge for like rare diseases.
Huge, yeah.
Where doctors might not have a lot of experience to draw on.
It's called cross-modal retrieval.
Cross-modal retrieval.
So Titan can bridge that gap between images and text, helping doctors find those connections that they might miss.
And that rare cancer data set we talked about, it wasn't just used to test visual matching, right?
Right.
They also used it to see how well Titan could find similar cases based on descriptions.
Based on just textual descriptions.
Wow. So a doctor could describe a rare tumor.
Yeah.
And Titan could potentially find matching cases from all over the world.
Exactly.
Pulling from the experience of like countless pathologists.
It really highlights the potential of AI to democratize medical knowledge.
To democratize.
Yeah. Imagine a doctor in a remote area faced with a difficult case.
Yeah.
With Titan.
Yeah.
They have access to a global network of expertise right at their fingertips.
That is powerful stuff.
Yeah.
But we've also talked about Titan's ability to generate those full pathology reports.
Right.
I'm curious, how do his language skills play into that?
Well, creating a comprehensive report isn't just about, identifying what's on the slide.
Right.
It's about summarizing the findings.
Okay.
Highlighting key details.
Yeah.
And using precise language that pathologists and other doctors understand.
So it's not just like spitting out data points.
Yeah.
It's crafting a report that a human doctor could use.
Precisely, the researchers compared Titan's reports to those written by human pathologists.
Okay. Yeah.
The results were remarkable.
What did they find?
They found that Titan's reports were surprisingly detailed and accurate, often capturing key information like the tissue site, the diagnosis, the grade of a tumor.
Wow.
And even those very specific morphological descriptions that pathologists use.
So it's like having an AI that can not only see what a human pathologist sees, but also understand and communicate those findings.
Yeah.
In a way that's meaningful to doctors.
Exactly.
This could like streamline the whole process.
Streamline it and potentially reduce errors.
Reduce errors. That's a huge benefit.
Huge.
It raises some even bigger questions about AI in medicine. Like, if Titan can analyze both images and text this well, imagine what other hidden patterns and connections are waiting to be discovered.
You're right. And it gets to the heart of why Titan is so exciting.
Okay.
It's not just a tool for pathologists. Right. It's like a glimpse into the future of AI in healthcare, where AI can analyze huge amounts of data, connect different pieces of information, and help us understand the complexities of human health in ways we never thought possible.
Like we're unlocking a whole new level?
A whole new level, yeah. We're just scratching the surface.
Like medical understanding.
And as AI continues to evolve, who knows what groundbreaking discoveries are waiting.
This has been incredible so far. But let's bring it back to the here and now. I've talked a lot about the benefits of Titan.
Right.
But what about the challenges?
Yeah, the concerns.
Yeah, the concerns that come with integrating AI into healthcare.
You're right. With any powerful technology, we need to proceed with caution.
Caution.
And consider all the implications.
So what are some of the key things we need to be thinking about?
Well, for starters, data security and privacy.
Yeah.
We're talking about sensitive medical information.
Right.
We need to make sure that this data is protected.
Protected and used responsibly.
Responsibly, yeah.
Absolutely.
Yeah.
That's a huge concern.
Huge, especially with all the medical data being generated and shared these days.
So what else?
Another important consideration is access and equity.
Access and equity.
We need to make sure these tools are available to everyone who needs them.
To everyone, regardless of location or socioeconomic status.
Exactly. It wouldn't be fair if only certain hospitals or patients had access to this.
Right. It could really exacerbate healthcare disparities.
Absolutely. We need to think carefully about how we develop and deploy these technologies so that they benefit everyone and help reduce those disparities.
We've covered so much already.
I know, right?
But we're not done with our deep dive into Titan.
Okay.
Up next, we'll shift gears and explore those, real-world challenges and considerations. We're back, and, we were talking about some of the challenges of bringing AI into healthcare.
Yeah.
Data security and access being two big ones.
Absolutely. And they're not just like technical hurdles. They're societal ones. If AI is going to help everyone, we got to make sure it's used responsibly.
Okay, so data security, that's huge.
Huge.
We're talking about people's medical information.
Right.
How can we make sure that's protected when we're using AI like Titan?
It's a crucial question.
Yeah.
And thankfully, we already have strong data protection regulations. And these will need to be, carefully applied as AI becomes more integrated into healthcare.
So like what kinds of things specifically?
Well, strong encryption methods.
Okay.
Strict access controls.
Makes sense.
And clear guidelines on how data can be used and shared.
Right. So transparency is key.
Definitely patients need to understand how their data is being used.
Yeah.
And feel confident that their privacy is protected.
Absolutely.
Yeah.
And what about access? How do we make sure that a tool like this, like Titan, doesn't just benefit like the big hospitals or the wealthy patients?
That's where the open source nature of Titan is really important.
Yeah.
By making the model freely available, the developers have really taken a big step towards democratizing access.
So researchers and developers all over the world
can
use Titan, adapt it.
Yep. And even build on it.
That's huge.
It is. This type of collaboration is really key if we want AI to benefit everyone.
But even with open access, there are still challenges, right?
Sure.
I mean, you need the right infrastructure to handle these massive whole slide images.
Yeah, and the computing power to run these AI models.
Right, and not every hospital or clinic has that.
You're right. Infrastructure is a big challenge.
Especially in like resource-limited settings.
Absolutely. But we're seeing a lot of progress in computing power and data storage becoming cheaper and easier to access.
That makes sense.
And there are even efforts to develop AI models that can run on, less powerful devices.
So it seems like we need a multi-pronged approach.
Yeah.
Robust data security, open access, and innovation to solve those infrastructure problems.
Exactly. It's not a quick fix.
Right.
But I think with the right mix of technology policies and, ethical considerations, we can really use AI to transform healthcare.
This has been an incredible look into AI and pathology.
It has.
Titan is clearly changing the game.
It really is.
Not just for diagnosis, but for how we think about the future of medicine.
I completely agree.
It's an exciting time to be in this field.
It is.
And I can't wait to see what's next.
Me too.
If you want to learn more about Titan,
You should.
we'll include a link to the freely accessible GitHub page
Okay.
in the show notes.
Right.
And if you enjoyed this deep dive,
Yeah.
make sure to subscribe and share it.
Yes.
Until next time, keep learning and stay curious.